My name is Sharma. Welcome to Machine Learning in the Sciences, the podcast where we explore the intersection of cutting-edge, data-driven technologies and scientific research. In each episode, we'll delve into how data-driven technologies are being utilized in the real world. From biology to computer science, chemistry to ecology, we'll bring you insights from leading experts in the field and examine the potential impact of these exciting advancements. Stay tuned for some amazing conversations. Today, I'm delighted to introduce a pioneering figure in machine learning, Vasu Sharma. His remarkable career has spanned an array of breakthrough projects and contributions that have significantly impacted the machine learning field. In his early career, Vasu contributed to making Alexa, Amazon's virtual assistant, more efficient and capable of understanding and responding to a wider range of requests. At Citadel, a renowned financial institution, he utilized cutting-edge AI technology to identify profitable trading opportunities that would have been challenging for humans to spot. His contributions also extended to academia, specifically at Carnegie Mellon University, where he worked on making AI smarter and safer. He developed ways to protect AI systems from manipulation and enhanced technology that can recognize and interpret facial expressions, contributing to the groundwork of how AI understands and interacts with humans. Today, Vasu is at Meta, working at Facebook AI research on large-scale multimodal foundational models. Furthermore, he is also interested in generative AI research and self-supervised learning at Meta. So whether you're a researcher, data scientist, or a science and technology enthusiast, sit back and get ready for a mind-broadening conversation. Together, let's delve into the boundaries of machine learning, virtual assistants, finance, and security. Welcome to Machine Learning in the Sciences, Vasu. It's an absolute pleasure to have you.
Glad to be here.
So let's start off with the first question, and the first topic really, which is optimizing AI for multimodal devices at Amazon Lab 126. So we've all witnessed how devices like Amazon's Alexa have become integral parts of many homes. These devices seem to understand our commands increasingly well. They can even track our movements to, ensure that the display faces us. So this remarkable capability involves something called multimodal transformer architectures. So could you explain this concept?
Mm-hmm. Sure. So multimodal transformers essentially are like this new cutting edge model space which has been taking over the entire space of multimodal machine learning these days. They originally came out for natural language processing field. There was a paper from Google, pioneering paper, which introduced this architecture to begin with. And then people kind of extended it to the domains of computer vision, speech, and pretty much everything after that. And they kind of formed the foundation stone for all the cutting edge research we're seeing these days, all the way from generative AI to embodied AI to robotic architectures. Pretty much all the machine learning models are kind of built on top of these transformer architectures. And multimodal transformers are basically just the multimodal extension of that, which are capable of processing multiple modalities at the same time. So it could be the text part of it, it could be the speech part of it, it could be the vision part of it, it could be the video part of it, it could be the 3D data, processing all of these different modalities across in a single model. That's essentially what multimodal transformers enables us to do. And that, of course, powers Alexa as well, as we know it, because as you mentioned, Alexa has like a lot of these different modalities it takes as input. So it could be like the user talking to them from an audio perspective. Then you have a text-to-speech model, speech-to-text model, which converts a lot of these spoken instances to text, which is what the system understands. And then it gives you an output from a text-to-speech perspective on what it speaks. And then it also processes the image part of it. For example, the following part that you mentioned. So that's both the image part of it and the motion part of it, which is the video aspect of it. So being able to process all of these modalities all at once is something that this multimodal transformer architecture enables. So yeah, that's kind of what the multimodal transformer model and its contribution to this whole thing is.
So how exactly has it kind of changed? So you mentioned that it's been used in a lot of different AI sort of fields. So how exactly has it revolutionized and really changed the way that we understand AI today?
Sure. So I think one of the biggest things is the data aspect of things. For example, a lot of the prior models that kind of existed before that were not able to leverage the amount of data that was being thrown at them. And also in terms of scale of the model architecture itself, they started hitting like bottlenecks. You can't just keep adding layers on top of the existing models from a deep learning perspective. They started hitting bottlenecks like vanishing gradients and a lot of these other problems which incurred just based on how these architectures are structured. Transformers kind of got rid of a lot of those issues. One of the biggest issues they got rid of was like the sequence sequence length in terms of like the length of whatever sequence they're trying to model. So from an NLP perspective, think of it as like just the length of the amount of text that is processing. So the architectures before that, which was probably the most popular before transformers came around, was the LSTM, or the recurrent neural network architectures. And they, based on the research that was done on them, it was very well observed that beyond a certain point, they just could not retain any context prior to that. Now that's a problem, because a lot of these conversations, they could be hours long, and you just didn't have enough compute power to kind of model all of these long-term architectures, or just the volume of data that was being thrown at them. They just were not able to handle it beyond a certain point. Transformers kind of changed that, because they have this thing called as a self-attention architecture built into it, which basically takes the entire sequence and computes like this attention matrix on top of that, allowing it to model pretty much an arbitrary length of a sequence without losing any of this information. So that was probably like the key advantage that these transformer models offered to these sort of architectures. And then the same thing was extended to the other fields, as I mentioned. Like, for example, you can think of the image also as a sequence of pixels. We don't usually deal with pixels. We usually combine them into like patches or some other format. But yeah, think of it also as like a sequence, either a 1D sequence or a 2D sequence. And again, you can have a transformer processing a lot of this information. So pretty much in every field from there to image and then speech and all of those things can potentially leverage the same sort of architecture, model these long-term dependencies, and still be able to process this amount of data and learn from a much larger amount of data, while also being able to utilize all of this increased compute that we had access to now.
So would you say that this is the direction that we're kind of going into? Is this technology going to be further implemented into let me rephrase. What can you see this technology being implemented to in the future?
I think everything, honestly, everything's pretty much being built on them. So earlier when they came out, they were designed for a very different use case. Now with the whole ChatGPT and all of these other generative AI models, you can see them also becoming like the foundation stone for all of these models. So people are unlocking potentials from these models that no one was aware of like at the time they were created. So far till nothing better comes around, let's say, these things are going to be foundation stones for a long time to come. But yeah, as the field evolves, it progresses really, really fast. So maybe like the next development is just around the corner. Who knows?
Yeah. So artificial intelligence has already started to make decisions for us, from playlist suggestions to personalized news recommendations. A major breakthrough in this context is the idea of embodied question answering. So what is this, and how might advances in this field impact our daily interactions with AI?
Sure. So embodied question answering, or embodied AI in general, is basically the idea of having like a robotic system or like a virtual assistant or something like that, which is not just able to see like a static environment and reply to that, which is what a lot of the systems before that was doing, but also be able to dynamically interact with the environment and kind of change its states and kind of analyze that environment and give you a response based on its interaction with the environment. For example, let's say you have a robot which you ask to find like a specific item inside, or let's say a virtual environment. Let's not deal with real environments right now. Let's say we have a virtual environment and you ask a robot a very specific question like, oh, could you find where I put my glasses, for example? Now this robot cannot just see one single image. It has to go around the entire house in that virtual environment setup and look where the glasses could potentially be. So it has to actually be able to traverse that. So navigation is one aspect of things. Second is being able to understand how the relationships work. For example, something over a table versus something under a table versus something inside a drawer. So just be understanding how these interactions with this environment work. For example, it might have to open a few drawers and shelves and tables and desks to also look for those glasses. So how does it understand that, oh, this is a shelf, I could possibly open it, there could be things inside it. So learning all of these interactions and nuances with its physical environment and being able to use all of that knowledge and apply it to the task that it was kind of assigned. So that's kind of the notion of embodied AI. It's a very big problem space, still potentially unsolved, but capable of unlocking like this massive potential of having personalized home robots doing a lot of your job for you, which is still something that's not there yet. I think we're still at a stage where we're still kind of exploring the space and just kind of touching the surface of it. But hopefully in the years to come, we will be at a point where a lot of this low-level tasks, for example, could potentially be taken over by these robots helping us out in the house.
Yeah, so I want to get more into this. Is this like sort of taking context from what it's done before and trying to further its actions through understanding the previous context? So like if we take Alexa and we ask it to play an album, so we say, Alexa, can you play a music album for me? would it from that point make it so that it would ask you, would you like to listen to country music or would you like to listen to pop music? How would that, is that something that would happen?
Absolutely. I think it does keep track of conversational history. So it is aware of the kind of questions you asked it before. And it also kind of keeps like a rough estimate of who you are as a person, what your likes and dislikes are, what other topics you're potentially interested in, and give you more suggestions in that space. And you can obviously have like a follow-up conversation with it where you ask it something, it gives you a response, and then you ask it a clarifying question or ask it to do something based on the previous response that it created. So it does have a notion of a context history, which it keeps, which it can use to potentially personalize its conversation with you.
So what are the upper limits of this context history? Like so say that I've been talking to an AI for 30 days in the same chat, like if you go to ChatGPT and you just start talking to it and say that it has more of this advanced embodied question answering. What are the upper limits of this context
I
history?
think the upper limit honestly keeps changing. It could have been potentially much longer earlier, but with the new privacy regulations and stuff, and also just people being more aware of the privacy aspect of it, a lot of this information is usually shredded and not kept. And there's a lot of personally identifiable information from this which is removed to make sure that there is no way to be able to link a lot of this information to a specific user, so that you can't actually track users that way. And you only keep the information which is non-privacy violating. So I think that's privacy has become a big concern. So most of the companies which are building in this space are taking this thing pretty seriously. So I think that bottlenecks the kind of history that you can keep more than the technological aspect of it. From a technology perspective, I think you can keep potentially arbitrary lengths of history. I don't think there's anything stopping you from doing that anymore. It's more of the privacy concern which restricts that.
Yeah. So this is just conversation. This would be like given a user and an AI model's sort of history. But what if we kind of replace the roles where the AI was kind of developing itself by talking to a human instead of a human trying to figure something out by talking to an AI? Would it be possible to kind of instead of creating a sort of user profile, but create a profile of itself and get on I don't want to say consciousness, but I do want to say get onto a sort of advanced point where it has like a personality, but it's not conscious.
Absolutely. So what you're referring to is called as online learning, essentially. That is being able to update yourself throughout the journey of being deployed. So for example, there's a model deployed. It's not stuck in time. It's kind of learning as you go along. So different ways of doing that. Some could be like you gather all of the data that's been collected since the point you last deployed the model to the present state of the model and then just retrain on that existing amount of data. Some could be that as you keep getting this data, you make small adjustments to the model. So you can't do like a full pass towards the model and keep updating all of the parameters. Are just too expensive. So you could potentially make like these minor adjustments to the model based on the new information that you're receiving. So there are different ways of doing online learning, and depending on how much compute you have, what your use case is, you kind of vary what you do essentially. And Alexa also looks for user feedback and response and kind of uses that feedback and response to kind of train itself, and similarly to any of the other models like that. So there could be different ways of responses that which kind of it can kind of learn from. So one could be just the average session duration. For example, if the user is interacting more with Alexa, it's possible that it's a good conversation and the user is actually getting the kind of responses that it wants to get. So that's like a positive signal that yes, okay, the user likes what we're kind of returning to it. On the other hand, if it's a very short session duration pretty much all the time, then it could be like a negative feedback. So that could be one. Second, it could be like a more explicit version of this feedback where it asks the user, are you satisfied with the response I provided, or did you get the information that you wanted to get? And user will explicitly tell you that no, I'm not satisfied with the response, or yes, I am satisfied with the response. And that could be like more explicit feedback that it could learn from. So there could be different ways of getting this feedback and using this to kind of update your world state, as you may call it.
So this, I feel like this is kind of an interesting branching point into unlocking like human sort of kind of mimicking humans. So what if we could, load in, say a person has died and they have a bunch of pictures, they have written a diary, which has all their thoughts and everything. Would you be able to, using, these transformer techniques and generative AI today, would we be able to like train AI true question embodied question answering. Sorry, would we be able to kind of
recreate the persona of some sort?
Yeah, and have just conversations with them.
So you don't need embodied AI for that. That's kind of a different branch where it's more like to do with the dynamic environment. But yes, generative and AI itself is something which can potentially use this prior data that we have for that specific person and recreate their personality. So there are two parts of it. One is like the conversational aspect, like generating the speech aspect of it, which honestly I think has become more and more feasible. Now we can regenerate people's speech just from a few minutes of their audio samples. So it's a pretty actively researched area, and it's doing a pretty good job. So you can potentially recreate people's audio just from a few minutes of their voice samples. So that could be one way to kind of building something that you can talk to. The other part is like the way they respond, like the textual aspect of, or the content aspect of what they say. And that also is kind of falls squarely in the domain of generative AI. And there's a company called Character AI, which is kind of already working on that. They're trying to create personas of people. Right now they're targeting more famous people. Like you could have like an Elon Musk bot or like some big person's bot based on the public information that you have on them, and just recreating how they would normally talk and just creating a chatbot that you can talk to based on that specific persona. But you can use the same sort of model and technique and apply it to someone else. Like if you have enough data on them, you could potentially build a chatbot which does talk like them actually.
So I was listening to the Lex Friedman podcast with Mark Zuckerberg, and he actually introduced the idea of this online persona where you can upload, like you can take sort of your texts, your Instagram, Facebook, LinkedIn posts, all of that stuff, and have someone who have a persona online that kind of can communicate with that. In what way do you see, like, would this be something that would be feasible? Would this be something that people would use?
Absolutely. I think this is something that could both be built and something that people are very interested in using. For example, celebrities, like there's not an easy way for like celebrities to talk to everyone, right? But people are sometimes very crazy about certain celebrities, and they would love to have a chance to just talk with them, or even like a lookalike persona for that way. So being able to build these chatbots which do talk the way that their favorite celebrities, or even like a human being. For example, you mentioned that what if someone passes away and you have all of this data about them, and you want to create like this memory of them where like there's this bot which you can talk to potentially, and the responses would be very much similar to this person that you're kind of referring to. So I think with the present technology we have, we're already in a state that we can actually build these things.
Yeah, that's very interesting actually. So you introduced the idea of people being crazy about their favorite celebrities. So I want to kind of get into the psychology of human and AI interaction, and this is something I've been kind of interested about. What makes humans humans? What is the difference between AI and human, or all these kinds of things. So I was wondering, would AI interaction be sufficient for a human to feel healthy about themselves psychologically? Would AI interaction suffice for that if we can get to a point where we have these personas?
Honestly, no. It depends a lot on the person, right? Like a lot of people, they care more about the physical touch or just the physical presence of a human being. For them, probably not. For someone who just needs like words of affirmation, or someone who's hasn't had a lot of that physical interaction with people outside, possibly yes. For example, the movie Her would like you to show that yes, so something like that would probably be enough. But yeah, in a lot of cases, you actually need the physical presence of another human being, or the comfort of just having that presence around you. So honestly, it depends a lot on the person. For me personally, I don't think AI persona would suffice. But yeah, for a lot of other people, it might. So if someone's like really, really depressed or really, really lonely, maybe not, it's not like a 100% solution, but maybe it's like a 60% solution, which is still better than not having anything at all, right? So it's like a step in the right direction that way.
So then would AI suffice for therapy?
Again, potentially yes, potentially no, but it's a very risky territory, because therapy is something that can make or break personalities and the human psyche. You would not want it to go wrong. So I don't think the technology is still at a place where I would trust purely an AI alone without any supervision to be a therapist for someone else. It could be like a good step one where like it's kind of helping another therapist actually deliver that sessions, or something which kind of talks about less controversial topics where like you're just kind of keeping someone company or just talking to them about their daily life or something like that. But something where, for example, you're dealing with like a serious situation or like depression or mental anxiety disorders and things like that, I probably would still not use, even though AI might actually be really good at this already, I would still not be at a place where I would let it do that without supervision. But yes, I do foresee that in the near future, we might have the technology to actually make these models self-dependent when they can actually do these kind of jobs. But yeah, so far, we're probably not yet there.
Okay. So let's move on to our second topic, employing machine learning in financial markets. So cross-asset class alpha construction is a process of identifying and developing trading strategies that can generate alpha across different asset classes. Alpha. Could you explain more about what alpha is and cross asset class alpha? All
Sure.
these things.
So alpha essentially is just a financial term for a machine learning model, which basically could take a variety of different inputs, and the output would essentially be the price of a certain underlying asset over a period of time. It could be like, for example, as a very simple example, let's consider the stock of Apple. So taking on a bunch of different data, you could have like, for example, just the historical price of what Apple looked like, or shareholder estimates of what it would look like, just public sentiment as sensed from like Reddit or Twitter articles or something like that, or just like analyst reports and stuff like that. So there could be a different amount of data that you could be getting, and you could be processing this, feeding it to a model, and that model would be predicting what the price of Apple stock would look like. Could be anywhere from like 1 second in the future to like 60 days in the future. So a model which can ingest this information and output a future value for a specific asset, that's what we call as an alpha.
And how accurate would you say such models that are, well, I guess, are alpha models being deployed currently in market to make financial decisions?
Absolutely. Honestly, I think most of the financial industry has actually moved away from manual trading. For example, if you used to remember the times of like the old eras where you used to see all of those movies, there were so many people on the floor which are like actively shouting orders, taking phone calls, placing orders, bids and all of that. I think most of that has actually gone away. It's pretty much an archaic stereotype. Not a lot of people do that anymore. Most of the trading, at least for the big companies, has actually moved away to this automated version of trading where it's a model or like an alpha, which is kind of trading on the market rather than actual human beings trading on the market. So the part has moved away from being actual trading versus to building these alpha models which do the trading aspect for you. And they're much faster. They don't need to make phone calls. They can do this online. And because of the arbitrage, it's actually made markets much fairer and much clearer, even for like a regular investor. For example, earlier, there's something called as a spread, which is basically a difference between the buying price of a stock and the selling price of a stock. It used to be really high. Massive margins used to exist before that, where you're buying something for, let's say, like $100 and selling it for $102. Big margin, like $2 is like a 2% margin over $100 stock. But now these margins have shrunk down to like maybe a few cents. So the markets become much more fairer, much more efficient that way. That there's not a lot of this arbitrage to be able to exploit, because if you allow models to exploit this arbitrage, they can make a lot of money very quickly. So the quality of these models enables the market to actually become more efficient and kind of sort of self-regulate itself without having to need any external influence to regulate it.
Okay, so I have two thoughts in mind. I'm going to start off with my first. So what are the steps or how exactly would you go about creating an alpha model? It's very generic.
Absolutely. As a personal investor or as like a company?
As a company.
Okay, as a company. I think the first would be acquisition of data. Data is probably like the key source which a lot of these things are built on. Your model is as good as your data is. And in this specific domain, that most of the data that you have is extremely, extremely noisy. So it's not as clean as, like, for example, the academic research we do or like a lot of the industrial research that we do. Models are really good. They can get up to like 80s and 90% accuracy on pretty much most of the tasks that they do. In this space, that's not at all true. You'd be very lucky to even get the direction right. For example, Apple stock moving up versus moving down. Even if you get just the direction right, you can actually make a lot of money off that. So these models so far are not that good that they can make a very, very accurate prediction. They can't. But point is, they don't need to. Even if they make like a suboptimal prediction, as long as they're right more often than they're wrong, they actually give you a pretty good leverage on terms of what you can do in the market. So yeah, I think that's what the present state is. And yeah, coming back to your original question, how to build these models, the first would be just collecting as many potential data sources, and data in the space is not that easily accessible. Most of that is like kind of gate marked by a lot of like these bigger companies. For example, financial data is kind of gatekept by Bloomberg. Bloomberg terminals are expensive, and a lot of these people kind of buy Bloomberg terminals to kind of just get that financial data to use that, and that's pretty much one of the biggest things that Bloomberg does, right? So they make a lot of money off of that, and they have a lot of expertise in the space. So getting something like that, or getting access to all of this Reddit and Twitter data, and a lot of like financial expert data also comes in. There's a lot of third-party companies which also provide these data to a lot of these bigger companies, which they kind of use as a leverage on their own strategies as well. So there's a variety of different data sources to kind of get this from. So that'll be like the first starting point. You need that. Second is to come up with efficient ways of processing all of this data and converting, because this is raw data, right? You can't use it directly. So first you have to clean it. Second, you have to process it. Third, you have to convert it into vectorized forms, which can then be fed into these automated models, like machine learning models, which can make sense of this. Third aspect would be building those models itself. Fourth is now you've predicted the stock price of Apple in the future, for example. What do you do with that? Like just the price enough is not enough, right? So let's say now you have $100 to trade with. How do you spend those $100 in buying whatever you want to buy? So you have predictions, let's say for all the Fortune 500 companies. Let's say your model guessed what the price for each of those Fortune 500 companies would be in the future. How do you allocate that budget you have over all of these different stocks, and how would your portfolio be like? So that's the aspect of building a portfolio, constructing a portfolio. So that's probably the next aspect on how you would allocate your capital to that. There's a bunch of other factors which come into play, like the market risk. For example, investing $1 in Apple is not the same as investing $1 in a company which just IPO'd yesterday. There's a lot more volatility in that particular stock compared to Apple. So you have to also keep in mind what level of risk you're willing to take. Second is transaction cost. If you trade on the market very frequently, every trade that you do incurs a cost. It's not a free trade. There's still like some margin which you have to pay every time you trade in the market. So if imagine a model is trading every few seconds, it'll lose a lot more money in terms of transaction cost versus something which is trading only once in like a few hours, something like that. So you also have to keep into account like that transaction cost aspect of it. So there's a bunch of different parameters which kind of go into building these things, and at a very high level, that's roughly what you need.
Okay, so I think this is a good point for a break. Thank you everybody for watching the podcast so far. This is Vasu Sharma, and we'll be heading into our break. Thank you.
Thank you.
Thank you to the City of Montessorino for their continued support of KCAT Public Media. The City of Montessorino has enabled KCAT to inspire, educate, entertain, and inform our community through the magic of television and digital media for over 38 years. Thank you.
Thank you for watching Machine Learning in the Sciences. I'm talking to Vasu Sharma today, and we're covering virtual assistants, finances, and security in machine learning. Thank you. So let's go on and continue talking about finances. So if you took, say, a normal investor and pitted him or her against an AI, an alpha model, how well would one do compared to the other? Is there like one sort of who would come out on top, I guess?
Honestly, I would mostly say the machine learning model, just because of the amount of data it has access to. Because it's not just about investing in one stock, right? It's about looking at the entire market. And there's no single human being which can go through all the amount of news that's out there, all the stocks, understand how they work, understand the historical averages, the dynamics, how they've reacted to certain situations in the past, and able to understand them and use that to predict the future knowledge. There's very, very few people who are smart enough to do that. I'm not saying that no humans can beat the AI models. There are humans which are smart enough to do that, but then they can definitely not invest in like so many stocks. They'll probably pick like a certain subset of the stocks, do very well thorough research on those specific subsets, and just invest in those. Yes, they can probably do that, but they'll miss out on a lot of these other opportunities which exist outside of that smaller domain set of stocks. But at an average, I would say average human investor cannot outperform an average AI model in investing on its behalf.
So what would you say is like an average AI model? What would that benchmark be?
So when I say average AI model, I assume that we're talking about like the hedge funds and the investment banks and all of that, which are investing on their behalf. Now, they have a lot of capital to throw at this. So the model that's being built for them, it has seen so much of data, has just analyzed historical patterns, statistics, all of this skill of already qualified traders, also building on top of that and kind of feeding their knowledge, injecting that as a part of the model pipelines itself. So it has a lot more to make its decision off of compared to an average human investor that way. So I would probably say that they'll outperform an average human investor at most times.
Yeah. So is there like a way we can get this to consumers? So business to consumers where, we sort of have a manager of your investment assets, which is a human, and then we have like an AI model that's making all the main decisions from time to time so that, these companies can be more efficient in managing their clients, so that you have one manager who's managing maybe 30 clients at a time or whatever, more than the average with an AI business, with an AI trader. How would this look? Are there companies that you can maybe think of off your head, and how would this work?
Honestly, yes. I think the B2C space in the investment side of things is something that's very lucrative and still relatively under-tapped. I'm not saying it's not tapped at all. There are companies which are doing that. There's a few companies like deeptrading.io. Each of the investment banks itself has like an arm. For example, Chase gives you a robo-investor. Fidelity gives you a robo-investor. Schwab gives you a robo-investor. So you do have an option to have a robo-investor kind of taking care of a lot of these investments for you. But they're good. Then it's not like they're not good, but I do think that there's scope for improvement even there. So if there's like a new player in the market which is able to do much better than these guys, I think there is still opportunity for people to do that. It's still not a fully saturated market that way.
So let's have a little bit of fun with this. Would you allow an AI to manage your retirement fund?
Absolutely. I kind of built like a mini play demo project and just gave it like $100 to trade on my behalf.
Yeah.
I've done that a few times, and yeah, it actually does pretty well. It probably outperforms me investing personally.
What was your ROI on the?
I ran it for just a few months, so it was just ran for about like 3 months or so, and I got about like 11 to 12% return on those 3 months.
Nice. Yeah.
Not too bad.
Yeah, that's very interesting, and that's super cool. So let's go into the next question. We're all aware that the financial world can be volatile and complex, with the stock market's ups and downs influencing our investments and economy. Machine learning is playing an ever-growing role in this field, specifically in crafting trading strategies. So what are specific strategies that machine learning models employ to get the best return on investment?
I think at the bottom of all of this, it's a regression problem. You take all of this input data sources that you get, process them, clean them, convert them into vector forms, apply some sort of a regression model on top of it, and the output of that regression is essentially the price of whatever asset you're trading with at a certain future date. So at a very rough nutshell, in the most basic form, that's essentially the model. So honestly, any regression model, all the way from linear regression down to like really deep, complicated, deep learning models, that entire space is fair game. You can use any of these models to kind of do that job. Most times what happens though is the input data that's being fed into these models is extremely noisy. Now the problem with that is that when you feed data like that, most of your models tend to overfit, and they learn more from the noise than they do from actual data. So being able to extract that very small amount of information that's kind of hiding among this large volume of noise within that data, it's not the easiest things to do. So none of your typical traditional models which you use in like academia or like more of this applied setup that people have been using, typically they don't work for the financial sector. And another problem with the financial sector is that it's not something that has a lot of open research that way. Most of the good strategies and things that people built, they're very confidential and kept in silos within these companies, because that's just how the nature of the thing is. You actually, end of the day, you're competing with other people. So if you make your secret sauce public, then the other people will start using the same thing, and you lose the arbitrage that you've created on top of that. So people are not very open to kind of sharing a lot of the knowledge that they acquire internally. And because of that, there's not a lot of literature that's kind of available in the tech space. It's just not available in the finance space. They're very closely guarded secrets that way. So yeah, that's not the easiest way to find out models on which would actually work. You actually have to get your hands dirty, try out a few things, see how they react to certain situations, and then use that expertise to actually build these models. It's not the easiest thing to do.
Yeah. So you created those models. Did you employ any specific strategy that helped you gain that 10 to 11% ROI?
Oh, the one I built personally? I was, honestly, it was just like a fun toy project. So I was just trying out a bunch of different things. So something as simple as like regression trees to linear regression actually does a pretty good job. If the interesting thing there is, how do you process the data? The model honestly is not the interesting aspect of it. How do you get the different sort of data sources which the model can learn from? That is actually a bigger and better problem than the modeling aspect of it itself. Any simple to complex model can actually do a reasonable job here. How you get that data, how do you clean it up, how do you process it? That's where the fun is. And in terms of building the model itself, yes, there's certain models which tend to outperform other models. But if you just want to do something which beats like a human investor, honestly, you can do that with like any simple model, even simple linear regression. Not the vanilla linear regression that's out there, that with good regularization and just being able to understand that the data is noisy and how to kind of work with that noisy data can actually outperform most of the humans out there.
So would it make more sense to, I guess, create a platform where you can create a portfolio, and it's kind of like Reddit. So you have a Reddit sort of platform, and you can create an investment portfolio, and the only thing you talk about on that platform are different stocks. And based on, public opinion of the stocks, is it possible to predict where the stock is going to go next?
Absolutely. And in fact, people do that already. For example, I know a lot of people use the sentiment on Wall Street bets, for example, as like a signal on like whether a stock would do particularly well, especially in the past year or so. Wall Street bets is a pretty major force in deciding where certain very small subsection of stocks would move. But honestly, that's true for a lot of the other subreddits which have been doing this much longer, which have I would say people taking longer and saner bets compared to Wall Street bets, which have just been like one-off instances of stocks. They kind of are actual experts in part of those subreddits which make predictions. There's a lot of other people which also post their own personal opinions on Twitter or Reddit and stuff like that. And these are like valued investors who do a good job overall. And these could also be good learning signals to a model being trained on top of that. So there's just a lot of data out there. You just need to be smart enough to figure out how to get it.
And I just want to add to the users, this is not in any way any financial advice, just so that, we can make this clear. I don't want you guys to lose $10,000 trading. As more trading processes become automated, many of us are curious about the implications for the financial future of our markets. As machine learning scales up and accelerates in the financial sectors, what potential impacts can everyday investors expect? And we kind of covered this before, but I think can go a bit more into this now.
I think the biggest part is just making markets more efficient. Markets today are way more efficient than what they used to be. Earlier, there were massive gaps within the market. There were opportunities for people to exploit them. There was a lot more arbitrage, so you had to kind of look out for those opportunities if you actually wanted to make it big. These days, it's more about value investing. You invest in things, especially for a human investor. I would recommend people to go more towards value investing, trying to understand underlying value and what they foresee could potentially be good in the future, and kind of feeling their gut instinct and going for that rather than trying to find those inconsistencies, because the markets honestly become very efficient. Not a lot of these exist. The inconsistencies have gone down significantly more.
Could you explain more about arbitrage and what that is? I haven't heard of that term before.
Sure. For example, something as simple as you buy something from one market for $100 and in a different market it's selling for $110. So you just buy it from one market and go sell it at a different market at $110. For example, as a very hypothetical example, let's say on New York Stock Exchange, something's selling for $100, and Chicago Stock Exchange, the same thing, someone's buying it for $110. So you buy it from the New York Stock Exchange for $100, go to Chicago Stock Exchange and sell the same thing for $110. You made $10 without actually doing anything. So that, in a very rough sense, is what you call arbitrage. So these sort of opportunities existed when the markets were not as efficient as they are these days, when there was no automated trading, when there was no electronic ledgers and all of these records, when you had to do physical paper trades, for example. From that till today, things have just changed drastically. You don't have paper ledgers anymore. Everything's online. Everything executes within like microseconds. So a lot of that has kind of gone away. So there's less arbitrage to exploit the loopholes in the system, let's say, and more towards like just value investing aspect of things.
And you said before that now it's more, value investing. So could you explain more about that?
No, that's for a individual and private investor, like someone like, for example, myself investing. Value investing essentially means me trying to analyze what the intrinsic value of a particular stock is. For example, if I feel that, I see Apple, I see they're building something good, and I feel that they could do potentially well in the future, they're still undervalued for the value that they provide to the market. Then I potentially, that belief would make me think that Apple's stock price will go up in the future. And just based on that conviction is why I would invest in Apple that way. So that's what's called as value investing, where I'm kind of trying to analyze the underlying value of what a particular company provides to the public. And based on that, I'm deciding whether or not to buy something or not.
Right. And so a platform or where you take data from subreddits would be a form of value investing.
It would be, yes.
Okay. All right, so let's move on to our third and final topic, researching AI vulnerabilities and advancements. So we hear more and more about data breaches and cyber attacks in the news, and the security of AI systems has become a global concern. You've done extensive work on defending AI from adversarial attacks. So could you explain what such attacks are and why this is a crucial issue?
Sure. So AI models are being deployed pretty much everywhere these days, all the way from facial recognition scans to something like Amazon Go, where you can just like walk out of the market essentially but just based on like the amount of information you picked up, or amount of products you picked up, without actually having to physically check out at a grocery store, right? So you can potentially think that there's a lot of scope for attackers or some malicious players to kind of exploit these AI systems, trying to fool them and exploit this systems in a certain way. So that's where the defense of these networks kind of come in. The adversarial part is basically, think of it this way, that if I modify the input of a particular machine learning model just by like a slight amount, and it's so subtle that to a human eye, you actually haven't made any change. It's exactly the same as what it would normally look like. But for the model, there's a drastic difference based on just that slight amount of change, and the output that model will give based on that slight difference could be significantly different from what it would give if that perturbation was not made. So that's what called as an adversarial attack. It could be just like a very small amount of noise added in very specific regions, which are imperceptible to the human eye, but for the model, it could be like a very, very big thing. So that's one of the problems that AI models essentially deal with. That's just how brittle they are in terms of like any sort of modifications in the input, and that way, because they're kind of designed to be very sensitive to certain patterns in the data, and that's how they do so well. But this is also a problem for the same models, that because they're that sensitive to very, very specific sort of inputs, if you exploit that sensitivity, you could actually get these models to make wrong predictions without humans even realizing that they're making the wrong predictions. Most cases, that's okay. In certain cases where you're deploying it in, like, for example, fraud detection or facial recognitions to access to secure facilities or things like that, or like just medical use cases and things like that, you cannot afford these models to be so brittle. So that's where the defenses of these models come in, where you try to modify these models in a certain way where you're not hurting the model performance. The model is still as good as what it used to be, but at the same time, you're making it less brittle, less sensitive to certain inputs or certain perturbations within the model itself. A very simple example could be just adding a little bit of noise to an image which is imperceptible to the human and designing in a certain way that it affects only those regions in the image which the model actually looks at while making a decision. Could break the model. But what if you try to train the model in a way that it becomes insensitive to specific regions, and rather than focusing on very specific areas, it focuses on like the whole global aspect of the image. So in that case, you can kind of protect these models from being exploited by just adding a little bit of noise to it and kind of fooling the model. Very, very basic use case. But yeah, that's essentially what the adversarial attacks and the defense aspect for that is.
Yeah, so in the image example that you provided, let's say that to avoid this attack, we add some noise we take a face, right? Mm-hmm. We add some noise maybe near the eyes or something. Mm-hmm. At that point, the model is trained. Is it only trained to defend against attacks that are near the eyes, or like? And can we layer different? If so, if it's only trained for the eyes, can we layer more sort of models to kind of defend against other attacks in different regions of the face.
Absolutely. So the example you provided, that's just one example of how you can defend it. Like, for example, if you give it training images of use cases where like humans with some noise added to their eyes and still the same sort of label, then it learns to avoid that specific type of attack. But that's just one type of attack. There could be a lot of different types of attacks. So to be able to protect against all of them, you can't just keep adding permutations and combinations to your data set. It's just infinite possible potentials that thing can do. So you need to come up with more generic solutions. You need to identify which are the most sensitive areas. For example, you said eyes. Eyes could be like a very sensitive area on a face where adding even a little bit of amount of noise could completely mess up in model output. So you need to identify what those areas within the face in this example is, which the model is the most sensitive to, and try to make the model to be less sensitive to those specific areas to make sure that no one can kind of come and exploit those specific regions. So that's one way to defend it. Another example, for example, is like just ensembling models. So instead of having one model make a decision, you have multiple models which look very different from each other make a decision. So each of them will have their own vulnerabilities, but put together they might kind of block each other's vulnerabilities. That's it. It's like protecting the blind side of the other models essentially.
So on your first point, you talked about getting like generic areas and kind of figuring it out. So I'm just kind of shooting out in the dark here, but would a technique be like creating two AI systems? One injects an attack into the image, and then then obviously the other one tries to fix it so that it kind of
Absolutely, that's one way to do it. You can have two AI systems kind of playing this min-max game against each other. One being kind of posing as an attacker, adding certain amounts of noise to it, trying to optimize the objective of how many times was it able to fool the actual AI model. And the AI model's task is to be as protective against this attacker as it could potentially be. And this could, in theory, be like just like a game between them. They're both trying to optimize different objectives and just play this game with each other to try to fix the model.
Yeah. So what are some other defense techniques apart from just creating the model and playing a game?
There's a lot of them. For example, the game thing is one we just came up with. The other is ensembling, as I previously mentioned. Third is identifying first of all these vulnerabilities. For example, for image use cases, a lot of time it's noticed like there's certain regions called as like the salient or the attention regions of an image. So what that means is that all of these models focus on these specific areas in that particular image to make a decision on what the output would be. So those areas are probably the most susceptible areas in terms of like the attack injection. So if you can protect these areas, you can actually do a good job. So one simple way would be to actually artificially induce noise in those sensitive areas, feed those to the models with the same label, and allow the model to learn that, even with noise added to these sensitive areas, the output probably still remains the same. So in that case, it can potentially learn how to avoid these mistakes. Another way is to use gradients of the model. For example, the most sensitive areas of a model would potentially be the spots where the highest amount of gradient flows back to the original input image. Because what gradients essentially signify in this case is that even a slight perturbation in this specific pixel would create a very large amount of change in the output distribution that the model is outputting. So you can just try to analyze those specific pixels and protect those pixels from being vulnerable that way, and allow the model to kind of learn that, don't be sensitive to the specific pattern. So things like that essentially are some examples of how you can defend. It's a very wide body of research. I can't list down all the methods, but those are some of them.
Okay. Let's move on to the next question. So facial recognition technology is not just science fiction anymore. It's increasingly a part of our everyday lives, from unlocking our phones to passing through airport security. With this rapid advancement, there are several public concerns. So what should the public be aware of as facial recognition technology continues to evolve? And this is kind of similar to, injecting adversarial attacks, but in terms of the public, what should the public be aware of?
Absolutely. So I wouldn't go into the adversarial attacks aspect because we already talked about it. But besides that, there are other concerns too. Right? Privacy is a big concern, that you don't want your face to just be available out there, especially in a time like this where generative AI models are using a lot of this public data to recreate images. You don't want your face to be a part of that data set where like it can recreate your face in certain scenarios. You don't want that. So keeping your face private and not putting it out there in general is the responsibility both for people and for the companies who have access to this data. So it's a twofold responsibility. As a user, you should be aware of what you're putting out there. And as a company who's building models on top of this data, you should also be aware of regulations on what you can and cannot use. The good thing is that the legislation space in this case has actually caught on with a lot of these models. People are much more aware of their rights and what and these companies are being asked to make sure that they're not using data in certain ways, and they're good at actually following these laws and orders, which is good. That they're taking precautions in the kind of models that they're building. They're respecting the user privacy. They're only using faces that they're actually either licensed or they have the right to use as a part of their particular machine learning models. So the privacy and the legislation aspect of it is something that's ever evolving, and hopefully it'll keep getting better over time.
So this is kind of a fun question. Say you had twins, right? Identical twins. Is just by comparing, I mean, if we're going on a facial recognition system, is there how would we differentiate from these twins? Just, I mean, we could go through with DNA or some other identifying features or fingerprint, but just from complete facial recognition, artificial intelligence perspective, how would that look?
Honestly, in some cases, the facial recognition system these days are so good that they actually distinguish between twins as well. So some of the very, very advanced systems have like an accuracy of like 1 in almost like a billion. And we have like 7 billion, 8 billion people in the world. So there's very, very few probability of it actually going wrong. Apple ID actually demonstrated when it came out earlier, Apple ID, the Face ID that Apple uses, it demonstrated that a lot of cases it actually is able to distinguish between even twins, because it's not just using the face itself, but also like a 3D structure and a lot of like point clouds, very detailed point clouds of the faces as a part of the algorithm. And I think that in itself, even within identical twins, there are minor differences in how the face looks like. And with the level of resolution that Face ID or similar technologies offer, it's sometimes able to capture even those minor changes between the faces across twins. Sometimes it's even able to capture that. But I wouldn't say that it's 100% foolproof. Yes, twins could potentially still fool the system in some cases, especially in like low light setups or occlusion setups and things like that. But I would say the technology is actually pretty good. In some cases, it can actually distinguish between even twins.
So with all these privacy concerns, why shouldn't people just use their passwords? Why is facial recognition important to be implemented in different systems?
I think it's just an ease of use, to be honest. Like, for example, passwords are still pretty secure. I wouldn't say 100% secure. They can be hacked as well, of course. But it's just the ease of use, right? You don't want to keep entering your password every single time that you use it. And with the way people use passwords, a lot of time the passwords are actually pretty easy to crack. And that's something that's existing for a very long time. And it's actually much easier to hack than being able to hack the face aspect of it, I would say. Just because people are predictable at the end of the day, they keep passwords in a certain way, and hackers exploit the repetitive nature or like predictable nature of human beings to actually guess those passwords. So I wouldn't say passwords are entirely secure either. So both of them come with their own risks, but the face recognition technology is much easier to use than that password is to begin with. So I think it's the ease of use that people are going for more than the actual security aspect of it.
Okay, let's move on to your work at Meta. So from what you can say, what are you currently working on?
So I'm working on something called as a multimodal foundation models, essentially, which is a part of the generative AI space. So you saw ChatGPT, for example, but that's purely text only, right? So think of it like a multimodal extension, something which can also like access images, access the text aspect of it, and a bunch of different modalities, and being able to learn from that, both from converting all of these and making guesses about what different tasks could be done on top of that. For example, just based on an image, like just trying to guess, answer a specific question on the content of an image, like it's called visual question answering. So that could be one potential downstream use case. You can have a lot of these downstream use cases. So that's one aspect of it where you do all of these downstream performance things. And second is to be able to just generate both text, image, and a lot of these other modalities at the same time. So that's the generative AI aspect of it. And given how cutting edge it is these days, a lot of this is something that is still kind of coming to terms with and kind of figuring out ourselves as we go along. But I think it's a pretty active and very exciting research space that we're working on. So that's one aspect of it. The other is the self-supervised learning aspect of it. So there is just a lot of data we have out there. So much of data, but most of it is unlabeled. So the problem with unlabeled data is that you can't use it directly to train a model because it just doesn't have a label. You don't know what to use it for. Being able to find these techniques which are able to leverage this volumes and volumes of data that exist and build models on top of that as like a starting point for a lot of other models which are more refined to a specific task. So this kind of serves as like a first level model training process on top of which you kind of build other models. So that's like essentially the idea of self-supervised learning. So I'm also looking at that space and how to kind of best leverage this internet scale of data essentially.
Okay. So let's move on to the final section of our podcast where we'll just be discussing kind of interesting things in the field of machine learning and AI. So I think the biggest question out there is, will AI ever be conscious? So what do you say about that?
Ever be conscious is like a very future dated concept. It might someday be conscious, but that's like, is that going to be conscious in the next few years? I don't think so. I think it's still a long way away. A lot of the news that we hear about it being conscious is honestly just fear mongering at this point, because what these models are able to do, for example, take ChatGPT for example, a lot of this is just trained on human data. So it's not actually creating new content. It's not expressing its feelings. It's not expressing what it actually thinks. It's just kind of repeating the kind of patterns it's seeing humans do based on the data that it kind of has access to. It's just literally repeating that information. So it's not creating new information. So I wouldn't say it's conscious that way. And given how these things actually work and how these things are actually trained, I don't think it at least in the present setup, it can't actually create new data that way.
So then what would be your definition of consciousness? Because it's a very hard thing to sort of define, and it varies.
Absolutely. It's very hard to define. I would say something, a body which is able to kind of think for itself and create new information which doesn't exist anywhere, express its thoughts, express its feeling, express its ideas, which don't actually exist, which are very novel to that specific person or body in this case. I would say that's partially, in my sense, consciousness.
Yeah. So then, if you essentially just took a human body and you took out everything except for, let's say, the lungs, the heart, and the brain, would that still be considered a human? So what would you say, as we're coming into the world of like, is it AI or is it human? What makes a human a human?
It's a very hard question to answer because even within human beings, there's so much diversity, right? Some people have certain parts, some people don't have certain parts. There's no one single definition of what constitutes a human. But one common thing between humans is that, yes, they're able to express their thoughts, emotions, and feelings in a way that's very unique to them and feel all of these things as well. So they're kind of creating new content that way, expressing their emotions in unique ways that's creating content. They're not doing that based on what they've read in books or something like that. They're doing based on their own personal experiences, their worldviews, what they've kind of seen in their entire life, and their personal opinions about certain matters. So they're kind of creating this new content. They're expressing feelings which are very novel and specific to them. So in my opinion, that is what the consciousness aspect of a human being is.
Okay. I have one more question. This is kind of off topic from that, but what are some resources that you use to stay up to date with AI? And
Oh, that's a tough one. There is just so much information, honestly, out there, especially if you're working on generative AI. Every single day, there's like hundreds and hundreds of papers which are coming out. So it's hard to kind of keep track of everything. So yeah, you kind of go off of what becomes popular. There's a lot of papers which kind of catch the media's attention. They kind of start trending on news outlets, on Twitter, on Reddit, on LinkedIn, a lot of those cases. So you kind of pick up those things. Then you also kind of keep tracking certain things on the particular problem statements that you're actively working on. So if anything comes out in that, you also read that. Then there are a bunch of reading groups and just like people sharing these papers across within, like your colleagues, for example, sharing with you, oh, I saw something that's very relevant to what you're working on. You should probably take a look at that. So a lot of this is like the new, absolutely cutting edge things. A lot of times it's just kind of this reading list that you kind of build up over time, which keeps forever increasing. You kind of just go over that, pick up a few papers from there and also read that. But yeah, reading and just staying up to date in this field is extremely, extremely important just because of the pace at which it moves.
Yeah. So I wanted to thank you so much for coming out to the MLITS podcast. Unfortunately, this is the end of our time. So this is Vasu Sharma. This podcast was about finance, AI assistance, security, and his work at Meta. It's been great having him here, and I hope to talk to you again soon.
Likewise.
So,
Thanks so much for having me.
Thank you. Thank you so much for tuning in to this episode. We hope you'll join us again soon for another episode of Machine Learning in the Sciences. Before we sign off, we'd like to give a special thank you to Zach Benitez and the rest of the team at KCAT TV 15. I'm Yash Sharma, and keep exploring the exciting world of machine learning.